In this lesson, we're going to examine some word problems. We're going to be trying to optimize them. When you're trying to optimize a solution, you're looking for the best solution, the highest, the lowest, the greatest, the least. In other words, you're looking for the vertex. Okay? The words we're going to come across most of the time will be the words maximum or minimum, but we should understand that that means the vertex, the highest or the lowest. There's two ways we can go about doing this, and they depend on the situation that you have, the format that you have. Okay, the first format you could have is factored form. If you have factored form, you need to find your zeros. And then you need to average them so you can find your axis of symmetry. That's the key to finding the vertex, because the vertex is made up of the axis of symmetry and the optimal, that's what you really want, value. So factored form, if you average your zeros, you can find your axis of symmetry. Once you know that, you can plug it into the equation and find your optimal. Totally works. We also have a second situation. We might have standard form. If we have standard form, we can't really see our zeros. We have to use our little equation we've decided. Okay, negative b over 2a. That also gives you your axis of symmetry. And again, you can plug it back in and get your optimal. So we'll go through two examples, one of each, just to remind ourselves of how this is going to work. So this first example says, determine the min or max value when it occurs. Well, if I look at the first example, I have standard form. I have ax squared, where a is 1, bx, and c. So I can use my formula way. I can use negative b over 2a, or in our case, negative 12 over 2 times 1, which is negative 12 over 2, which is negative 6. Once I know that, I can plug that back into my equation for all the x's. Make sure you put in brackets, because you want to square the sign and the number. If you do that properly, you should end up with negative 26. Okay, the question said determine the min or max value when it occurs. So we have to answer this now. I got the numbers, what do they mean? So the first part is it a min or a max? And I can tell that based on my a value. A is positive, that means it opens up. If things open up, they have to look like this. If they look like this, they have to have a min. So what it therefore is, it's a min of negative 26. And we got that when x was negative 6. And that's a standard form one. The second one looks more like a factored form in that it has two separate brackets. So if it's in that form, we have to find our zeros. Now one of these zeros is pretty easy to find. X is 4. The other one's slightly more tricky. I have to figure out what makes it equal 0. So I have to solve this. So I get negative 1/2. So if I want to find my axis of symmetry this time, I have to average my zeros. I've got the 4 plus negative 1/2. I'm going to turn it to a decimal just to make life easier for us. That'll give us 3.5 over 2, which is 1.75. Again, once I know it, I can plug it back into my equation. So I can put it in for all the x's. So 2 bracket 1.75 plus 1, and 1.75 minus 4. And my first bracket comes out to 4.5. The second one, negative 2.25. And if I multiply that together, I get negative 10.125. Okay, so there's my math. What do I have, min or max? This one's slightly more challenging to tell because the a value is not exactly given. It's not usually the a value is out front, right? So in this case, because I have a two-part bracket, this one, two parts, it makes sense to multiply. Think about FOIL. If I were to multiply those together, I'd end up with 2x squared. And the number in front of x squared is always our a. So it's a 2, a positive 2. That tells me it opens up. If it opens up, it has a min. So I have a minimum of negative 10.125, and I got that when x was 1.75. Okay, so there's our two styles. Now, lots of people don't like the average of 0 style when it gets those messy decimals. So they say, I prefer to do standard form. So if you had chosen to take this equation and FOIL it, let's do some FOIL here real quick. And we collect our like terms. We get 2x squared minus 7x minus 4. And then you could use this method. X equals negative b, in our case 7, over 2 times a, so 2 times 2. We give you 7 over 4, which comes out to 1.75. Same answer as that one. So if you prefer, you can always FOIL, put it into standard form, and then just use negative b over 2a all the time. Some people like that way better. Some people like the zeros way better. Your choice. Two different ways of doing the same kind of problem. For our purposes today, our equations are basically in the standard form. So we're going to use a negative b over 2a most of the time. Let's take a look at the first one. And all we got left here is examples. Okay, we're going to go through some basic types. I'll try one. I would suggest you pause the video and you try the second one yourself each time. So we have Jasmine. She makes necklaces for her market stall. Her daily profit from making X necklaces is given by P equals. How many necklaces should Jasmine make per day to maximize her profits? Here's my key word, maximize. That's a vertex. But a vertex is made up of two parts. It's made up of the X part, and in this case, the P part. So what am I being asked to find? I'm looking for how many necklaces. Necklaces are the X part. But really, I want to find the axis of symmetry here. X equals negative b, here's my b value, negative b over 2 times a. Or in other words, negative 20 over negative 2, which is 10. Right? She should make 10 necklaces to maximize profits. I found the axis of symmetry that creates the vertex. Part B, find the maximum profit. Well, there's the second half of the vertex. In other words, let's plug that back in. So negative, and then 10 squared plus 20 times 10. In other words, 100. So to continue my therefore, she should make 10 necklaces to maximize profit. Her max profit is $100. So these two things together is the vertex, right? The 10 from the axis of symmetry and the 100 from her optimal value. All right, part C. What happens if Jasmine sells no necklaces? In other words, what happens if X is 0? Well, if X is 0 and I put 0 into the equation, I end up with P is 0. In other words, she makes no money. What point on the parabola is this? This is our y-intercept. Our y-intercept is our initial value, which if you recall is always this c value, which is over here. There is no c value. C is 0. Okay, because in this case, if she doesn't make anything, she doesn't make any profit. That kind of should make sense. She makes no profit for no necklaces. Okay, so there's our warm-up one. I'm going to get you guys to try the next one. Okay, same kind of question. See what you can do with this one. A computer software company models profit again using this equation. So we've got a slightly bigger equation. X is the number of games produced in 100,000s. That might be a key. And P is the profit in millions. Okay, what happens if the company doesn't sell any games? In other words, if X is 0. Well, if X is 0, my initial value says negative 9. That's my C right there. What does that mean? No games sold results in 9. Remember, profit was in millions. So $9 million lost. They put all the money into production, advertising maybe, and they don't sell any, they lose all that money they've put in. Okay, let's do part B. What happens if the company sells 400,000 games? Okay, so X is 400,000 this time, except for X was given in hundreds of thousands. So if X is hundreds of thousands, this is really just the number 4. So if X is 4, what happens? Well, let's put 4 into our equation and see what point that comes out to. Okay, so all into our calculator, and we should get 7. Okay, 400,000 games produces $7 million. Remember, it profits in millions. Okay, part C. How many games must the company produce to earn the maximum profit? Okay, so I'm looking for the vertex. Vertex is made up of two parts. Am I looking for the x or the y, or in this case, the x or the p? The question was, how many games? Games is x. So I'm looking for the axis of symmetry. So x equals negative b. So negative 20 over 2 times a. Or in this case, negative 20 over negative 8, which comes out to 2.5. What does that mean? Max profit if 2.5, which means, remember this is hundreds of thousands, 250,000 games are produced. Okay, just a wild guess. D is probably going to ask us about what is the maximum profit, and sure enough, that's what it is. In other words, what's the optimal value? So take our axis of symmetry and plug it back in. So P equals negative 4, and we're just using that equation right from the top there, right? We're using an x value of 2.5. If I put that all in, I think I get 16. Yes. Okay. Max profit is $16 million. And that's kind of our typical word problem where we have an equation. There are other things we can do, but money ones are kind of the standard thing. And we often want to know what the initial value and then the maximum, the vertex. Okay, second half of the lesson, we're going to look at some shape problems. Shape problems involve shapes, and we often look to optimize shapes, find the best possible shapes. So I'm going to take you to the first one, and you guys try the second one. They're of a similar nature. So rectangular field, we divided as shown below. The farmer has 160 meters of fencing available. What are the dimensions that give the maximum area? And what is this area? So here we go. We're thinking about the vertex. Optimizing the best. Well, the first thing I need is some dimensions. So I'm going to call this the length of the rectangle, which will make this the length of the rectangle also. And I'm going to talk about this being the width, which then tells me that if I add all this together, my perimeter is 2 lengths and 4 widths. And I know my fence is actually going around the perimeter, around the whole shape and through the shape, so I actually have 160 meters of fencing. But that's about as far as I can go with that equation because I have 2 variables. I can't solve it for 2 variables. So I need a second equation. Now if I go back to the question was about area. Well, we know that area is length times width, which are letters I already have. In fact, if I take one of my first equations and rearrange, so I'm going to take this 4w and put it over here. Tell me what 2l is. And I divide everything by 2. I can actually write an expression for length in terms of how wide something is. In other words, I can take this equation and substitute it in for L. What that will look like then is L, what's L? Oh, it's 80 minus 2W times W. Well, now I have an equation that's only dealing with one variable. If I expand this and multiply it out, 80W, multiply that out, minus 2W squared, and I rearrange that, I get an equation for area in terms of W. In other words, I have myself a quadratic equation. I don't really need the other stuff anymore because I have an equation like the previous ones of money that depends on one variable, the width of this rectangle. If I can optimize this width, I can figure out the area of the rectangle. How do I optimize something? I find the axis of symmetry and I plug it back in. So in this case, I'm going to use negative b over 2a. It's standard form, but I don't have x equals. I have w's. So I have to use w equals negative b over 2a. or in our case, negative 80 over 2 times negative 2, which gives me 20. And once I know W, I can plug that back in. My area will be negative 2 times W squared plus 80 times W, which if I calculate, comes out to 800. And I got my solution. If I go back to the question for a second, just to point out, the question said, what are the dimensions that give the maximum area? And what is the area? Well, the area I can see is 800. The W, the width, is 20. So the only thing I'm really missing is the length. But the good news is I have an equation for length right here based on how wide the thing is. I know how wide it is. It's supposed to be 20. So I can plug that in. Oops, that's not 4W. That's 2W. Sorry, guys. I used 2W in the question, right? I didn't use 4. Just make sure. Yeah, I did. Okay. Fix that. 2W. 2W. That gives me 40. Okay. There's all the parts and pieces I need. So a max area of 800 meters squared with dimensions. Where do we get that from? 20 meters by 40 meters. If you check it, 20 times 40 does indeed come out to 800. So it makes sense. Okay, last one. I get you guys to try it. Same kind of question. See if you can figure this one out. Wendell wants to build a rectangular fence to pen his animals. He has $8,000 and fence sells for $5 per square meter, per meter. A river will border one side of the pen, so no fence is required to that side. Okay, so I got a river. And then I got fencing. Find the dimensions of the pen that give the animals the greatest area. And what is this area? So it seems like it's kind of standard question. I got my length, I got my width, I got my width. So my perimeter this time is made up of one length and two widths. But I wasn't told specifically how much fencing I have. But I could figure it out. I know I've got $8,000, and I know that it's $5 per square meter, per meter. So if I divide 8,000 by 5, I end up with 1,600 meters of fence. There's my perimeter. And I can rearrange this equation so I get one letter by itself, because I know that's a handy thing to do. So when I go to do my area is length times width, I don't have to use length. I can use 1,600 minus 2W times W. So I only have to deal with one variable at a time. I also know if I expand this, I'll get 1,600 minus 2W squared, and if I put it in the right order, I get this beautiful equation. That looks like a quadratic that can be used throughout the rest of the question. Okay, I want to optimize this. So W equals negative B, negative 1,600 over 2A's. 1,600 over negative 4, which comes out to 400. I want to plug it back in. If I do that, I end up with 320,000. And I need L. I got W, I got A, I need L, but I've got a nice equation for L right here. So L will be 1,600 minus 2 W's, and W we just figured out was 400. So I get 800. Okay, so Wendell needs to build. All right. A max area of 320,000 meters squared with dimensions of, let me figure out, the W is 400 meters and the length was 800 meters. And there's a standard kind of shape problem. So that's the end of that lesson. There's a couple questions I want you guys to try. There's some shape problems, there's ones with equations in there. Just get a chance to practice some things. You'll notice we generally use negative b over 2a, because that's kind of the the easier format to use because most of our problems are going to be in standard form. If you're stuck, come see me, and we're going to keep on moving throughout this unit. So this is a big idea you need to practice.